Hello, Turtle Lodge. Hello, Dave specifically. I wanted to make this video to communicate with you my vision that I had while I was fasting and how it relates to my research and cumulative effects in general, global warming, which is a cumulative effect, and I wanted to communicate it with you guys because I found it really coincidental that my lab that has trained me in a lot of what I've learned was put on this path of cumulative effects by the Saugeen Ojibwe on the Bruce Peninsula in Ontario. And through Turtle Lodge and life, I guess, I ended up with the Saugeen in Manitoba. And so what I had with my vision, I was out there, no food or water. I was on my third night, and it was just getting dark, and I was sort of falling asleep. And I found it really weird because when usually it gets dark when you fall asleep, it got light this time, and I was really withdrawn but connected with my surroundings. It was in a really weird headspace overall, but I closed my eyes and it went light and this curtain opened and there was this really cheesy musical that just went on and on for, it seemed like hours. I have no idea how long it was. I guess it could have been, I don't know. But it was just about how fake and detached and dysfunctional our modern society has become, and specifically that there's such an abundance of jobs but so few careers because everything's just so insincere. And with all of our environmental issues that are coming up, whether it's global warming, that would be the one that the media is taking a lot of interest in, but there's a lot of them: deforestation, habitat fragmentation, you name it. The bulk of the reason, it's not a lack of knowledge. If you consulted properly with scientists, if you consulted with elders or just people that genuinely have learned about and observed and been in the environment, it's usually a problem of indifference, just ignorance, insincerity in your interactions with the world around you, and it's just too bad. But I've got to be hopeful that the recent talk, with the Paris summit and everything, global warming, might bring the world around to maybe fixing some of those problems and just the systematic flaws that allow us to operate as negligently and unsustainably and just frankly irresponsibly with our planet, our giver of life. Literally every single life support system in the hospital 24/7. That's our planet, Turtle Lodge. Thanks. So let me get into this. I made this little talk because I wanted to try and focus my ramblings. I have a tendency to get sidetracked. And so yeah, let me get right into it. All right. So as I mentioned before, my lab was brought on to talk about cumulative effects in the early 2000s. Not me specifically, but my advisor and his advisor, um, by the Saugeen Ojibwe on the Bruce Peninsula, because they were recognizing that their fisheries were facing a number of threats. And having studied them for 3 years now, I can it's the face of our problems. All of our environmental problems right now are related to cumulative effects in some capacity, and it's just this next step in conceptual acknowledgement that we never do one thing at a time to the environment. We always put it under more than one sort of stress. And yes, sorry, I'm rambling. Um, the first point I want to drive home about global warming and fossil fuel is this conversation is not new. We saw pretty much everything about sustainability, about just the realities of the dirtiness of fossil fuels with coal 100 years ago. And for whatever reason, we seem to have forgot it. I'm going to emphasize these points. I'm going to go into a little bit more detail. Um, but a lot of it, especially from the simplistic view of carbon and greenhouse gases, we talked about all these points with coal. So with coal, this is when we saw the start in the rise global warming. Right around here is when coal was pretty much huge. Fossil fuels like gasoline hadn't really caught on yet, but people are noticing they didn't see the global warming, they didn't see global impacts, but they did recognize that on a localized scale, coal is just dirty. You know, if you mine it, you get the black lung. If you live in it, then you can get carbon monoxide and things like that. And you know, we vent it, but we're on a planet, so where are you venting it to, really? It's just dirty is not the way to do it. Gifford Pinchot, conservation hero, absolutely deserves that. I'd even say he's probably the father of conservation, as opposed to preservation. Where everyone else was saying, you know, wow, nature is beautiful, it's just a gift from God, we've got all this wood, we've got all these resources, thank you, God, and they just take it, you know. And Gifford Pinchot was one of the first that would acknowledge, he was a forestry guy, and he'd acknowledge, yeah, it's great, we got all these woods, but if we just take them all, then we don't have woods anymore. So he was the one that started to acknowledge that even if you're in a position where you're an industry that is harvesting from natural resources, you've got to, it's not just a gift that you can take. You know, there's strings attached. You've got to manage and take responsibly. Um, and you know, he wrote this book, The Fight for Conservation. It's available at this link in its entirety. And he's talking about coal, but if you read it, it gives me chills. Everything he says is just completely relevant, even today. Everything about sustainability, about just dirty industry, and just, yeah, you should read it. And you know, they had success. They moved away from coal in North America and the United States, but it's not really moving away from fossil fuels, because the bulk of what happened is we moved from coal to fossil fuels containing nitrogen, and that was just sort of innovative in our engines, because um, when you bring in nitrogen, that's two gases that it's making, so it's so much more potent of an explosion. It just, we made the gasoline engine, and the rest is just sort of history. Um, so yeah, now the second point I want to get to um, is that, sure, we've seen this before with coal, but with nitrogen in fossil fuels like gasoline, it's more than that. It's not just coal, it's not just carbon, it's not just greenhouse gases. You start to get into nitrogen, which is the building block of protein, so you just really start messing with things. You're introducing fertilizers to rain, it's a big problem. And sort of the drive home point that I want to get to is that when you have more than one thing that you're driving, it's not just greenhouse gases, it's not just carbon, it's also nitrogen. This is sort of cumulative stress. So even though you only have one thing you're doing, gasoline, you're doing multiple things to the environment, and you need to consider both of them at the same time if you're going to acknowledge the full scope of what your gasoline is doing. So yeah, gasoline has carbon in it. Gasoline is dirty, just like coal is dirty. It burns a little better, but you know, you're still venting it outside, pretending that that tailpipe's not going right back into your lungs. But again, with nitrogen, you introduce acid rain, you introduce global eutrophication, in the sense that places like fens, places like bogs. These are plant communities that only form in really, really nutrient poor environments. And so suddenly you're raining fertilizer on these systems, and you see fens turn into marshes. You see bogs. Um, Bogs are really acidic, so they'll hold the land as a bog. But if you ever had a fire that would burn through the bog or burn through boreal forest that contains bogs, if you have nutrient-rich environments, you're not going to get these bogs reforming. So not only are you going to release a bunch of carbon, which is going to be a big problem for global warming, but it's never going to reform as a carbon sink, um, like it was before. Um, so this is a little bit from my um, thesis, and it just gets into cumulative effects and just characterizes it. So the concept of cumulative effects arose in 1979. Pennock started talking about it conceptually, and it's been described as when individually minor effects occurring together in space or time result in a significant effect. Cantor talks about that. He describes it as death by a thousand cuts. But that's not the only form of cumulative effects. But in either case, by this definition, any single stressor input applied to an open system can interact with other inputs from other sources within the system and result in an effect beyond what you can see if you look at individual inputs. Um, and so basically what that is saying is that if you've got puzzle pieces and you study them in labs, in microcosm, and you have a really well calibrated toxicological understanding of how mercury is going to impact fish. Well, that's great, but it's not just mercury that they're facing out there. It's PCBs. It's also all the fertilizer runoffs and stuff too. It's never just one thing. It's always a bunch of things. And if you're going to look at the environment and try and ask, what should I do? Tackle the problem of sustainability. You really need to think of the full scope of what you're even doing to nature. Um, and this gets to the idea that global warming is one example of several cumulative effects, and they're occurring on global scales. This is the next point I want to make. We've got global eutrophication from things like fossil fuels, but also from things like agricultural runoff. Major issues. And we've also got the accumulation of persistent compounds. If you need a literal example, there's the plastics swirling in the Pacific Ocean, but there's also chemicals that don't break down, like PCBs. They're not going anywhere. Global eutrophication, major problem. Coastal waters everywhere. You get algal blooms, you get hypoxia, you get just nature's dying on a global scale because we're messing with it on a global scale. Plastic, size of states, bigger than Texas, just swirling around in the ocean. You can appreciate that there's all kinds of particles that are swirling around under the waves that we can't see. Um, again, just like global warming, this is a global scale problem. Everyone has to work together if we're ever going to solve these problems, and we can barely even scratch the surface of them. But you know what? They're not just global scale problems, and this is what we need to really drive home. Cumulative effects operate at all scales, from individuals to ecosystems. You've heard of bioaccumulation. Through your lifetime, you accumulate things in your body. It's not just individual exposure events, but if you've been exposed to something your whole life, suddenly the tiniest little dose of it is functionally a massive dose, and you die. Like, it affects individuals all the way up to ecosystems. We're seeing global temperature changes. We're seeing just change, drought, continent-wide drought. It's huge. It affects our lakes, and it also affects our forests too. Um, with our lakes specifically, a very current issue with our water is the issue of moving water out of our Great Lakes. You cannot mess with that, and I'm going to emphasize that point. And the Uralsi, we cannot forget about that. Underline that, circle it, do whatever you got to do. Google that after, and you need to read about that because you need to hear the story of the Uralsi. That's a big issue, and we're probably right now on the path to doing the same thing to our Great Lakes, and it freaks me out. So as I mentioned before, it happens on all scales, and the the people that got my study group together and focused on this was the Saugeen Ojibwe and the Chippewas and Nawash up on the Bruce Peninsula for their fisheries. They started off with this guy, Steve Crawford, great guy. I play hockey with him every Thursday. This is my advisor, Neil Rooney, and this is Dan Gillis, a statistician that I work with all the time. Um, they're they're really smart guys. They got a great team together, but it's Ojibwe that started this issue and brought it up to our group, and I think that's really cool. But this is my thesis directly. This isn't my work, but this is work done by Alan and others out of the States. They run this thing called Gleam. You can look them up on there. And in our Great Lakes, we're throwing all kinds of stuff at it, and they're sort of trying to go about it from a toxicology perspective, trying to even conceptually look at all the stuff we're doing. And they made this map that's pretty well known. I'm trying to do the same thing. I'm looking at the same issues with fish and seeing what the story of the fish tell us and see if it lines up with this story at all. And it doesn't line up at a system-wide scale. But if you go bay by bay, you look at Sarnia, you look at Grand Bend, you look at Goderich, you look at, Sable Beach, Wasaga Beach. If you look at those individual communities, then within those smaller scales, it appears to line up pretty good. So um, I guess the point of what I'm trying to say with all that is we're still at a level where even in the easiest to understand ecosystems, we aren't at a level of understanding that we could say that we definitively understand even what biological structures are reacting to human impacts, let alone the minutia that our policy demands. Like how much more can we allow to run off and things like that. We're way off being able to answer those types of applied questions. But the main point that I want to drive home with the Great Lakes is with a lot of American states in drought, they're looking to use their drinking water, freshwater resource, and pipe it to the states that are in need of water out of the Great Lakes. But there's a major issue with moving water across watersheds, and that is that when lake bed is exposed to the sun, it dries in a way that draws salt to the surface and nothing grows. So lake bed makes desert when you expose it to the sun like this. And in the Ural Sea, they basically, it was a lake, the smaller than Huron, but bigger than Ontario or Erie. It was a big lake in Kazakhstan, and they wanted to reroute some water for irrigation purposes in China in the 70s, and they started with this big lake, so they're just taking a little bit of water, and they took too much, and they drained the entire system, and it's now a desert. So if you live in the Great Lakes area and you have drinking water and you go fishing sometimes or wakeboard or whatever, um, yeah, you really care about people taking water out of your Great Lakes. You don't want to mess with water. That's a major issue. But you also see it with our forests. Root compaction is a major issue. You get into any urban cities in Ontario or Canada, there's only really a dozen or so species you'll find. You don't get a natural forest forming, and that's because of root compaction. But there's also issues like fragmentation of forests for things like pipeline right-of-ways or power line right-of-ways or road constructions. We cut lines through these forests, and you might ask yourself from a regulatory perspective, well, how many right-of-ways can you cut through forest before it stops being forest? And we're still trying to figure out what makes a forest a forest. So trying to ask from that angle is just, it's not possible, but our policy asks us to. And really, it just drives the point home that we need to have some more humility. We don't understand when it's all right to take what we're taking from the nature. Um, So we really need to ask ourselves what we need to take and think about that more. But an artifact of the urban stress on forests is we end up with really low species diversity within cities, and that makes it so that ash trees, for instance, are planted almost in monoculture in many city areas. And so when things like emerald ash borer get out of control and get into our cities, they can just completely kill everything, and you have entire forest collapse, and that's just, sorry birds, good luck. Like, there's nothing you can do about that. And it sort of alludes to this bigger point. Sure, we have understanding that we need to build on, but when push comes to shove, that's just going to give us our tools, and we really need the wisdom to know how to use those tools. And part of that wisdom is the humility to not use them unnecessarily. Although Leopold, that's his name, right? In Sand County Almanac, he mentions that all tools of humans, even in modern man, can be summarized as either a shovel or an axe. We can either plant things and we can create, or we can cut things down and destroy. And it's a simplistic way of thinking about it, but with our understanding of cumulative effects, you've got to think of it that way. Um, one quote that I came across is this one that's up there right now, and I read that. That's in these books right here, originally published in 1770s, reprinted in the 60s. Um, but Peter Kalm, who was part of the Royal Botanical Society or whatever, he was with Linnaeus, the guy that came up with our naming system. He made an observation, and I guess I'll just read this. Since the arrival of great crowds of Europeans, things are greatly changed. The country is well peopled, and the woods are cut down. The people increasing in this country have, by hunting and shooting, in part extirpated the birds, in part frightened them away. In spring the people still steal eggs, mothers and young indifferently, because no regulations are made to the contrary, and if any had been made, the spirit of freedom which prevails in this country would not suffer them to be obeyed. And he wrote that in his journal, November 9th, 1748, recognizing that we don't just kill nature, we also change the behavior. We can scare them away. We don't have to just kill them directly. He goes on to talk about fish. He talks about how he noticed from a guy in Boston talking about the local stream, that he used to catch whitefish all the time, but when he put in a dam to turn, or to grind whatever, mill his grain, he lost the whitefish. And once they stopped coming there, when he once they were never there, once they were eliminated from there, no fish would come back, even if he took the dam out. And this, it's just really fascinating. I highly recommend these books. Guelph Library has them, but I'm sure you can find them anywhere. It's called Travels in North America by Peter Kalm. And yeah, so the thing about cumulative effects that is really needing to be discussed right now is that we're not taking them seriously. Cumulative effects have been written in the Canadian Environmental Assessment Act since 1992. What's missing is an action plan, a method to be able to do it. We say that it's important, even in the current Canadian Environmental Assessment Act, that we need to be able to consider cumulative effects, but we can't, and we're not really putting too much of an effort into doing it. And you get the product of that is you get a lot of people talking about management goals, like all this stuff about carbon credit, like global warming specific action plans that aren't really action plans, but just kind of goals, incremental goals. And because there's no known methodology, or really widely accepted and well used methodology, progress is really hard, and there's not really measurable goals, even because we don't know how to measure cumulative effects. So I guess the punchline of what I wanted to say here is that if we're to take these things seriously, cumulative effects of all kinds, including global warming, including climate change, including taking care of our water, our forests, just everything, Turtle Island in general, um, it's got to consist of something like these 6 steps. And we've got to look at the world around us. We've got to sincerely and honestly look at what we're doing and how the world's responding to what we're doing to be able to manage what we're doing. So we really need to observe as much as we can from every perspective we can, in every way we can, in every language we can. We need to look at the world. Um, we need to take observations that are quantitative, so measurable, and we need to use statistics to be able to identify patterns. Because in a world where we're innocent until proven guilty, one unfortunate detail of that is that you can't just point to what's good and what's bad and what's better or worse, because we depend on our legal system to be able to stop people. Because if they're making money, they're going to try it unless they get sued and told to stop. So we need to bring our statistics and our quantitative knowledge in there to be able to use tools like our legal system. And we're not in a position to do that. And that's why our courts can't really police these things, in addition to regulatory policy issues. But that's another video. Um, I guess that's actually what I'm talking about right now. We need to watch the world. We need to use statistics to identify patterns that we see. We need to use science and scientists to figure out and quantify a mechanistic understanding of how this machine works, because we need to know how it works to be able to engineer it. Then we need engineering to come in and explore modification options. Just because something occurs in a certain pattern in nature doesn't mean that we can't modify it in an environmental or an urban setting to mitigate an adverse effect we don't want. We can build a fence to keep deer off the road, and that'll stop deer mortality on roads. We can engineer solutions. Um, but the big thing is that we need to create regulatory policy, to mitigate the adverse effects and use all of the above. We need to have science, engineers, statisticians. We need to have people involved in the process that have the skill sets to make it work. And most importantly, we need to repeat this process indefinitely. Adaptive management. Ideally, we'd use something like PUNTS management strategy evaluation. That's what they use in Australia with a lot of success, because it's really expensive, but it's really quantitative, and it's useful in court. So adaptive management, the whole idea is that even if we think we've figured it out, even if we think that we've, um, figured out how to have enough game in our forests to have, hunting and still have our right of ways and still have our roads, we still need to continue to watch the world, watch nature, because otherwise we're not going to see if something changes. This has to be a dynamic process. We all have to be involved, and we really have to think about it. Um, so I guess I'm going to stop there. Oh, actually, I should acknowledge I'm part of Create Great Lakes. This is where my funding is. These guys have kept me fed, and they've helped pay for some cab rides that I may have taken in Manitoba unnecessarily, potentially. Anyhow, that is about all I had to say. Um, Please get back to me about anything I've said or anything else. I'm looking to apply this education I've paid fortunes for, and yeah, looking forward to continuing this conversation. Thanks for listening.